Hi everyone. Today we are going to discuss the topic algebra. In algebra, we are going to discuss first topic is group. Okay. First of all, what is group? The definition of group is if G is a non-empty set and star is a binary operation on G. In this sentence, we need to know what is a non-empty set. We know non-empty means something is there, that's called non-empty. Then what is set? Set means, what is set? The definition of set is a defined distinct object considered as a whole. This is called the definition of set. So now we know what is the non-empty set, and what is a star is a binary operation. What is a binary operation? We denote as star. Star is a function which is mapping from x cross x to x. That is, suppose a star b equal to that star of a comma b. A star b is equal to some c, or otherwise we denote as star of a comma b is equal to some c. This is called binary operation. Now G is a non-empty set and star is a binary operation on G. Then G comma star is called a group if it satisfies the following conditions. What are the conditions? Closure, associative, identity, and inverse. And now we discuss what is closure. Closure means for every a comma b in G, that is, we have to choose any two element in G. That operation we need to operate that one. The resultant is also belongs to that G. That is, for every a comma b in G, a star b in G. This is called closure. And then associative. Associative means we need to pick a three elements in that set. That three elements must satisfy any three elements, not any particular elements. For any three elements in G, that three elements satisfies this condition. That is, a star b star c is equal to a star b star c. Then identity. Identity means in that group there exists an element E, we call as E. There exists an element E in G with a star E equal to E star A is equal to A for A. Okay, that's called identity element. Okay, and then inverse. Inverse means for all A in G there exists B in G, that is corresponding to A there exists a B in G such that A star B is equal to B star A is equal to identity. That is, group with a binary set with a binary operation satisfies these four conditions. It's called the group. The example of groups are Z comma plus, Q comma plus, and R comma plus, and C comma plus. Integers, set of all integers with operation addition, and then Q with addition, and set of all real numbers with addition, and set of all complex numbers with additions are the groups, which are not a group, not a group. There is natural number with a addition. Because why? In additive identity is is 0, and multiplicative identity is is 1. Please note this, additive identity is 0 and multiplicative identity is 1. In set of all natural numbers there is does not exist the identity 0. There is no identity element, that's why it's not a group. In set of all integers with the dot product is not a group, because why? There is no inverse for that element. In integers only plus or minus 1, plus or minus 2, plus or minus 3, and so on. So in each and every element there is no inverse. That is, suppose we take an element 2, the inverse of 2 is 1 by 2, but here we don't have that element, so Z comma dot is not a group. Then next we are moving to the definition abelian group. What is abelian group? a group G comma star is said to be an abelian group if it satisfies the commutative law. This law is called the commutative law. Commutative law. What is that? For every element a comma b in G, it satisfies a star b is equal to b star a. A group satisfies the commutative law, that is a star b is equal to b star a, is called the abelian group. Okay, so it shows that in group it satisfies the 4 conditions in a group, and a abelian group means it satisfies the 5 conditions. What are they? Closure, associative, identity, inverse and commutative. In example of abelian groups are z comma plus, q comma plus, r comma plus and c comma plus are the abelian groups, and z comma dot, q comma dot, r comma dot and c comma dot are not abelian groups. Okay, thank you.